Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Onwaka, and I am your instructor. Today, I'll be telling you the ultimate procedure to flat slab design. Now, these 10 steps, which I will tell you on how to design a flat slab, is the effective steps to perform a flat slab design perfectly. Whether you are designing with manual or you're designing with softwares, these 10 steps will work for you perfectly. Now, before we dive into the steps, I will have to tell you that there are some conditions you will see. It is best not to use a flat slab. There are also some conditions you will see, then it is best to use a flat slab. Knowing that flat slab can fit into any kind of structures, but despite that flat slab can fit into any kind of structures, there are some certain natural conditions you will notice or you will see in that country or in that terrain, then it is best not to use a flat slab. I will tell you that later at the middle or the end of this video. Now, let's now begin for the steps to design an effective flat slab. Now, before we begin, please, if you're new on Ekidel, consider subscribing. And to all our old subscribers, I thank you for being up to this stage or up to this end. And also consider joining our Ekidel membership here on YouTube. Okay, that's fine. So now for the ultimate procedures on how to perform a flat slab design perfectly, either manual or by using software. The first step you have to take is doing what? Understanding your building plan. Now, this first step looks very common and very simple. Yeah, that's fine. But like I said again, if you miss any of these steps, you will have issues on your flat slab design. So the first step is understanding your building plan. Now, when I mean understanding your building plan, what do I mean? Looking at this building plan now on my screen here, you can see that this is a building plan. Now, when you have gotten a building plan, the first thing to do is to understand the building plan. What are the features on that building plan? Do you have a staircase? Do you have a lift? A lift shaft? What kind of staircase do you have? What kind of lift do you have? How many lifts do you have? Where is do you have any void? All right, do you have any void on the building plan? Those kind of things are understanding your building plans. Also, are there claddings? You can see, are there claddings on the walls? What kind of claddings do they have? Is it metal cladding, heavyweight claddings, and all that? No. So you have to understand each of these things. Now, the level at which you understand your building plan is what will make you understand the next step, which is the step 2. All right? And the step 2 is going to lead you to the other step. So if you don't understand any of these steps which I'm mentioning now, then you will have issues understanding the next step. So the step 1 is understanding your building plan. It's very essential. It's very good to do that, okay? Now, the step 2, after you don't understand your building plan, the next step now is now doing what? Performing the structural framing. Now you can see, if you don't understand the building plan, how then do you frame your structure? How then do you know where to place a column or a structural member to be able to resist that or to carry what you understood on the building plan? So you can see why understanding the building plan is the number 1. It's the first step, okay? So the step 2 is the performing your structural framing or preparing your structural framing. Now, when you are on this step 2, I will say that this step 2 is almost 50%, if not 60% of what you are meant to do on the flat slab. This step 2, if it will take you one day, full 24 hours to do, don't rush it. Make sure you do it. Because once you have any issues on your structural framing. If your structural framing is wrong, then just know that your design will be wrong, right? Because structural framing comprises of your column positioning, your structural members like reinforced concrete walls, your panels for your slab, and other things comprises of the structural member. So, and structural framing comes from your mind, comes from your idea, comes from your brain. So, what you are trying to do at that particular time is to use your brain to frame, to carry the structure, to carry the load imposed on that structure. That is what you are just trying to do, to frame the structure against the building plan you have seen. Knowing that the building plan, you have already seen if there is a gym in the building, if there is some kind of features in the building. So you're trying to use your brain to carry the load of that by framing the structure. Okay, that's number two. So number two, framing the structure is very, very important, which comprises of your column positioning, where you have to position your columns. That's one. Two, if you intends to provide structural walls around the staircase and all that, then that is also that step two is when you are meant to do all that. Then your slab structure, how your slabs are going to be paneled and all that. It all falls on this step two. Okay. Then step three and also step two also falls on how to carry other upper stories and all that. So you also think about that on the structural framing. Then the step three now talks about choosing your member section sizes. Now that you have now tried to understand or perform, you have understood the plan and then you have performed the framing. Now this step three and this step two works hand in hand, which is choosing your member section sizes. Okay, because you cannot insert a column point without putting a size or choosing a size for that member. You cannot put a slab without knowing the depth of the slab which you want to use. Okay, for example, that's good. Then also you can put or insert a wall or put a wall without knowing the width and the length of that reinforced concrete wall or the thickness. Okay, that's fine. So this step three, which is choosing the right member sizes. Now on this step three, know that what you're doing is assumption. You're trying to assume the structural member, right? But you must have to assume based on what the code says. Either you are using BS code, American code, Indian code, China code, Japanese code, and any other code. They are still the same thing. You have to make sure you pick your member sizes based on the design code you are using. Okay, that's fine. Now, once you choose your member sizes, the first thing you are doing is assuming the member sizes, knowing that after the analysis and design, some members sizes or some members are going to fail. They might say that you should increase, or you might want to increase the member section because they can be able to carry the load. So the first thing you're doing is assuming, which is this step three, choosing your member sizes. You are assuming the structural size members. Okay, but you have to assume based on your design code. Okay, every design code has specified sizes for each and every structural element. For example, Eurocode or BS code states that the minimum depth of floor beams should be what? 450. And 450 is gotten from 150 slab depth and 300 beam. So if you add it together, that gives you 450. So the minimum floor beam that's having a slab should be what? 450 millimeter. All right. So different codes can have different can have different okay for that. Okay, that's fine. So right now The next step, once you're done choosing your member sizes, the next thing you do right now is to load your structure. Now, knowing that the first one, which is the step one, understanding your building plan, you have already understood the kind of features. Is there a gym in the building? Is there an office in the building? What kind of structure is that? Are they using it for office complex? Are they using the building for office complex, or for shopping mall, or for school, or for classroom block, or for no different kind of buildings for different usage? So you have already understood the usage of that structure. It is you knowing, it is by you knowing the what they're using that building for, then you can be able to load that structure, knowing that different design codes have different loads for different usage. For example, if you're using it for an office complex, Eurocode or BS code states that the life load for office complex is what 2.5 kilonewton per meter square. If it is for a residential building, Eurocode or BS code states you are going to use 1.5 kilonewton per meter square for the life load. If you're using American code, which is ACI code, the code states that you have to use 1.92 for every residential dwelling places. You have to use 1.92 kilonewton per meter square. So other codes too, Indian codes, Chinese code, and other codes states their own. Okay, so you have to go and choose and then pick what the code you're using says. Okay, that's fine. So the step 4, which we are on now, is loading the structure. Now, what I have just said is the life loading. When it comes to loading the structure, it comprises the dead load and the life load. So what I just said about loading by you picking from the code is the life load. Now you have to also consider the dead load of the structure. Now the dead load of the structure comprises of the partition load and the finishing load. Right? Now when a partition load can be 0.5 or 1.0 kilonewton per meter square, finishing load can be 1.0 to 1.2 kilonewton per meter square. So you have to join these two together and add them together, and also factor all the loads like cladding and all that makes up your dead load. Okay, now once you have formed this dead load, you have to add it up into your design load. Okay, and then the self weight of the members, for example, self weight of slab and all that. Now when it comes to flat slab design, the minimum depth of a flat slab design is 200 millimeter. Okay, 200 millimeter. But even if 200 millimeter is the minimum depth, it is not commonly used. The minimum depth that is commonly used is 250 millimeter. Most people go ahead to use 300. Yeah, so 250 millimeter and 300 millimeter are commonly used for flat slab design. Okay, that's fine. That's for the depth of slab. Then the step 5 we are moving in now is the completing the structural modeling. Now that you have understood the structure, you have done your framing, you have choose your member sizes, and then you have loaded your structure. The step 5 now is completing the structural modeling. Now, either if you're using an engineering softwares like Protastructure, Staadpro, ETABs, and all that, you know that you are meant to perform the structural modeling and all that. So you have to complete the structural modeling by adding how many floors, how many stories the building is, and then modify if there are differences in stories and all that. You have to modify each and every story to make sure it appears or looks to what the building plan says. Okay, and all that. Okay, that's fine. So you just complete your structural modeling. Now the next thing now is performing building design check. Now this step, if you're using an engineering software, you have to perform your building design check. For check, if the structural model which you have done is okay. You have to check for overlappings. You have to check if there are if a slab, or if you have any small area of slab, you have to check if there are overlapping between two slabs, or between two columns, all those stuff. You have to check for that. Okay, you have to check for overlappings and all that, and then check for clashes and all that too. So you have to perform building model check. If you're using manual design, the same thing. Check what you've done again. It's just about checking what you've done again, because after these steps, which is for checking, we are moving into step 7, which is performing the structural analysis. And when it comes to structural analysis of a flat slab, the best method to use for flat slab, in fact, the method that is used for flat slab design, is the finite element method of building analysis. That's what is used for flat slab design. Now, if you're using manual design, you are going to use only the finite element method of building analysis. Okay? Now, if you're using software like Protastructure, the software will require you first to perform building analysis based on yield line. After you're done with that, then you now move into the finite element floor analysis, where in that place you will see an option that they will give you to merge the build analysis which you have done into the finite element analysis. That's because they want an effective design. That's why I love the software Protastructure very well. They want effective design, and then you then move on to the next step. So the step 6 is what? The step 7, performing analysis, structural analysis. Okay, if you're using another software, ETAB, I think they have, you just run a finite element analysis. Okay, that's fine. That is the best method to use when you are performing a flat slab design. Now, after you're done with the structural analysis, the next thing now is to perform the structural design. All right. Now, the step 7 you did, which is the structural analysis, you have analyzed the structure to see if the structural, to transfer the effect of the load into the structural members carrying the structure. Now, don't forget that if you have any external loading, for example, wind load, seismic loads, and all that, horizontal loads and all that, it is on the steps of when we are dealing with loading, which is the step 4, loading, that you have to consider all this by loading the wind load and also loading seismic load. Don't forget, I said on the end of this video, I will tell you when not to use a flat slab design. Okay, so if you have any external loading, wind load and all that, you have to add it up on this before you perform the structural analysis. You must have finished up everything about loading, and you only add wind load to your structure when the height of the building or of that structure is more than 10 meters high, because it is only at that height of 10 meters a wind can affect your structure. Now, this law or this rule is not on structures that are on hurricane countries that experience hurricane, like Belize, Dominican Republic, and countries around the Caribbean region. If you are designing for countries around the Caribbean region, for example, Belize, I have done some designs in country Belize, that's North American, and all that. I've done designs in Belize. In that place, if you're designing for any structure, even if it's a gatehouse, you must add wind load because they experience hurricane a lot. If you're designing structures in Dominican Republic, you must also apply wind load, even if it's a 3 meters height building. Okay, but for other countries that don't experience hurricane, I know that it is only at 10 meters high that you can apply wind load to your structure. Okay, that takes us now to step 8. Now, on step 7, which we are dealing on now, we just finished the structural analysis. Now that we have analyzed the structure, carried all the weight, all the load, the self weight and everything, and generated our moment, our shear force, our reactions and all that, it is now time to use this value to then move to step 8, which is now the structural what? Design. Now, the purpose of the structural design is to design those structural members that have already gotten this effect, which are the moments, the shear forces and everything, the reactions from the load. So it's not design these structural members to see if the initial sizes that we assumed on the step 3, which we are to do choosing our member sizes. Don't forget I said that in the step 3 we assumed the sizes. Now on this part 8, we are now performing a design to check if those sizes that we assumed will be able to carry the effect of all the loads that we have considered. And now that we have now performed the structural analysis, we will now check. So we are now trying to check if these structural members that we chose, the sizes, for example, 400 by 400 millimeter column that we chose initially, the depth of slab of 300 millimeter that we chose, and the width of concrete wall, let me say 250 or 300 millimeter that we chose, if these structural members, the sizes, are able to carry or withstand the effect of this load, and also is able to withstand the structure and keep it in equilibrium. So we are going to check all this now. Now, once you have performed your structural design for this, the next thing now we will then move on to is to now perform punching shear failure. Now, when it comes to punching shear failure, I know that on the punching shear failure, the first you have to consider is to calculate the punching perimeter, the punching region, knowing that one of the failure mode of a flat slab is by punching. So either the flat slab without column drop or with column drop, one of their major failure zone is punching, is by punching. So that's why punching check is very, very crucial when it comes to flat slab design. You must take that into consideration. So you have to calculate the punching perimeter for each of the columns. You calculate the punching perimeters for each of the columns. You know the punching region. And then when you have known the punching region, you will now reinforce that region separately. This reinforcement now is called or are called the punching shear reinforcement or the punching reinforcement. Now, when it comes to punching reinforcement, after you have done with the design, let me assume that around around each of the columns or some of the columns, you are having a higher value in your area of steel, which increased or which will require the punching shear reinforcement after you have done your minimal reinforcement for the slab. Now, it's not time to now introduce the punching shear reinforcement around the column region. Now, in this now, let me assume that you are having the T20. If you're in Canada, that's H20. Okay, that's H20 or H16 or that H20. I'm saying about the bar notation. Different countries has different bar notation. For example, Nigeria, Ghana, other countries, African countries uses T or Y as their bar notation and all that. So I will just use T now as my bar notation. So if you have, let me say, around the column region, which is the punching, around the punching region, around the column, you are having T20, that means diameter 20 at spacing of 150 millimeter or 175 millimeter. So you can see, after you're done with your normal design for the slab, the normal design for the slab will give you the minimal reinforcement top and bottom for the slab generally. Then around each of the region of the columns, you now calculate for punching, which you now know the punching zone or the punching region. When you have known the punching region, you now design for the punching reinforcement. All right. So punching reinforcement, you now design for it. Most times, if the minimal slab reinforcement is, let me say, is enough, most column might not require punching shear reinforcement, but it is advisable to always provide punching shear reinforcement around each of the column, even if the punching shear calculation is adequate. Just provide a minimal punching shear reinforcement after you're done providing the minimal general slab reinforcement. That's fine. So once you have provided all this, the next step now is the what? Part step 10, which is what? The reporting and documentation. Now, in this area of reporting and documentation, this deals with what? Structural detailing, generating your structural reports that will back up your structure, that your structural drawing. Okay. Now, even if you have done an effective structural design and your detailing is wrong, forget it. The building will collapse. Good design, poor detailing, the building will collapse. Poor design, good detailing, the building will collapse. So for you to have an effective design or flat slab design, both your structural design and your detailing must be correct. So for example, you provided punching shear reinforcement during your design, but during the detailing, the perimeter which you said you want to provide the punching shear reinforcement, the structural detailer didn't provide enough reinforcement or didn't capture the actual region. What happens? It has failed. Yes, your design report was okay, your design was okay, but the detailing is wrong. So for a good and effective structural design, any design at all, your design, what you did on your design must reflect exactly to what you did on detailing. Right? So good design, good detailing, the structure will stand. Good design, poor detailing, collapse of the structure will happen. Poor design, good detailing will cause collapse of the structure. But good design and good detailing, perfect. You have a wonderful structure. That's fine. So now, once you've done with this now, reporting and all that, you can then move into the substructure. Now, for the substructure, that is not the story for today, right? That will be lesson for the next day. So I have just walked you through right now on the superstructural design, which is the flat slab structure. Okay, that's so these 10 steps are what to do when you are to design an effective flat slab design. Now, for bonus, don't forget I said that on the last part of this video, I will tell you when not to use a flat slab design. For the people that watched halfway, let me say 15 minutes and just left, then they didn't get this bonus. Now, when to use a flat slab design? When to use a flat slab design, like I said again, flat slab is economical compared to normal beam and slab. structure, frame structure. Flat slab is very economical. 2, it is fast. If you have a short timeline for your project completion, then flat slab can be used to achieve the short duration for the project completion timeline. Then flat slab also is used for aesthetics. In fact, is good for aesthetics. Yeah, it's very good for aesthetics. For example, you are designing a shopping mall, office building complex. It is best to use a flat slab. Now, flat slab are also used when you have larger panels. When you have larger slab areas, it is best to use a flat slab. There are other types of slab that can be used when you have a larger panels. For example, waffle slab, roof slab. But there are limitations on those ones. Now, when not to use a flat slab? Just one reason. Now, if you are in a country that have seismic effect, earthquake effect, it is best not to use a flat slab for that structure. The reason is because flat slab is not good in withstanding the effects of earthquake. So it has been done, approved and researched. Flat slab is not good for and when you're designing structures around the earthquake region, majorly on the earthquake fault lines. Alright, for example, in Jamaica is not good to use a flat slab design because of its weak axis, weak regions, weak joints. Right? That's good. That's fine. So if you're designing for countries that are having earthquake regions, it is not best to use a flat slab. You must have to advise your clients that flat slab cannot be used in this country or in this region because this region is an earthquake fault line. Right? That's fine. Thank you. So for those of you that have watched up to this end, I'll say thank you. And once again, welcome to Ekidel. Our next video will be on bridge design. So if you want to know that, I'll say you should watch our next video for bridge design. We have done complex videos on other type of structures. You can watch the next video just below or the one you're seeing just now after this video. Thank you so much and God bless you. Now, if you've not subscribed to our channel, please consider subscribing. And if you want one-on-one training, which is the Ekidel mentorship training, I would like you to check on the link down below and enroll for Ekidel mentorship training on structural design. We are also running mentorship training on structural detailing. That's fine. So the codes that we use to train on our Ekidel mentorship, we use BS code, Euro code, and ACI code. So depending on the code or the country you are and the code you use, we teach these three types of code: Euro code, BS code, and American code. So thank you so much and God bless you. I see you on the next video. Yeah.